All right, so we talked about circles last time, and they have the general form that looks like this. Um, and I'm just using A, B, and R. They're sort of classic choices. And what this means is that it's relatively easy to graph the circle. This tells you how far to the left or right. It tells you the horizontal translation. Now, if this had been x plus a number, that's the same thing as x minus negative that number. So what that means is if we have, for example, minus 3, we go 3 to the right. But if we had x plus 3, we go 3 to the left. Same thing for y. But generally speaking, we'd have the image. It would look like this. Here's the center of the circle, A comma B. And let's say here's the radius. And there's the circle. And we find the x and y intercepts. What do you really need to know to specify circle? You have to be able to say what the center is, and you have to be able to say what the radius is. And it's nice to be able to say what the x and y intercepts are. Not too bad. The x and y intercepts is a little bit involved, but we've done quadratic equations, and so that's a skill you have, and so that shouldn't be a problem. So let's do a specific example, and then I'll show you, yeah, there's a problem. There's a catch. That'll make this a little bit more difficult. So let's suppose we had this here, x minus 3 squared plus, let's say y minus 2 squared equals, let's just make this, for the heck of it here, let's make this 5 equals 9. And let's make a graph of this, and it shouldn't be that bad. Famous last words. So we'll go 5 to the right, 1, 2, 3, 4, 5, and then we'll go up 2, 1, 2, and there's the center. So that's, I want to say no math involved, close to being no math involved. The radius is going to be the square root of that, so the radius is 3. Now from the center here, here's the center, 5, 2. If the radius is 3, one of the things that we do want to graph also, aside from the x, y intercepts, are what are called the vertices. The vertices seems like an odd thing in circles, but wait till we get to ellipses, and the concept of a vertex will make sense, more sense. But at any rate, what you want to do is go up 3, 1, 2, 3. Now, what point would that be if we went up 3? Well, that would be the point 5, 5. Now, what if we went down 3? 1, 2, 3. So 5, negative 1. Now let's go over to the right 3. So 1, 2, 3. And that's the point 8, 2. Just counting blocks. And if it's a piece of graph paper, just 1, 2, 3 to the right, then 1, 2, 3 to the left. So 1, 2, 3 to the left. And we get the point 2, 2. And here's the circle. I'm not worried about whether it looks too fantastic. Well, one thing you notice, it is clear in this case from the picture there's no y-intercept. So we don't have to worry about finding y-intercepts. But let's find the x-intercepts. How do you find x-intercepts for any graph? You set y equal to 0. So let's set y equal to 0 right here. And we'll get x minus 5 squared plus 0 minus 2 squared equals 9. Let's go ahead and multiply this out. X squared minus 10x plus 25. You square that, you get 4. Subtracted from both sides, 5. Actually, what I should have done is subtracted the 9 from both sides. That would make more sense. How did I get a 25 there? Oh, that was from this right here. Well, let's go and bring the 5 over here. So x squared minus 10x plus 20 equals 0. Straightforward quadratic equation. Let's go ahead and solve that. We'll complete the square. Again, I don't care really now, how you. It's important to know how to complete the square. You'll see in just a few minutes why you need to complete the square. Particularly when we do ellipses and hyperbolas, you absolutely have to not complete the square. But when it comes to solving a quadratic equation at this point, I don't care if you use the quadratic formula, complete the square, or if it's factorable. I doubt that's factorable. I didn't really take too close. Wow, that was factorable. I think it's a minor miracle. Wait a minute. Most are not factorable, so you kind of get out of the habit of even trying to factor them. But let's see. That won't get it. No, it's not factorable. I don't know what I was was thinking here. So at any rate, okay, let's go ahead and complete the square. Take this, divide by 2, 5 squared, 25, add that to both sides. This should be, you know, old news, old news. It's factors, of course. Square both sides, and then add this to both sides. So you get x equals 5 plus or minus the square root of 5. Now notice the symmetry. You're going to have the symmetry because the circle is a very symmetric object. 5 plus or minus the square root of 5. Look at the x-coordinate of 5 right here. What that means is 5, we go the same amount to the right and the same amount to the left. So this point right here is the point 5 plus the square root of 5, comma 0. And this point here is 5 minus the square root of 5, comma 0. Right there and there. Now, the square root of 5, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, went too far. So the square root of 5 is about 2.5. So on your picture, you know, this should look to be about 7.5, and this should look to be about 2.5. If you were making a nice graph, particularly graph paper. Okay. So, and what, you know, the radius is 3. We have the center. We have the vertices, x and y intercepts. Everything is great, not too bad. So what's the possible catch? Well, let me show you. I'm going to leave this equation here because I'm going to work with this equation. Now, in a second, I'm going to ask you to pretend that you did see this equation here. Let's suppose some evil demon, maybe Laplace's evil demon. If you don't know Laplace's evil demon is, you can look it up. But let's go ahead and multiply this out. And you should ask, why would you be doing this? You wouldn't do this. You wouldn't want to do this. That's why I said suppose an evil demon came by and did this. And let's say we had x squared plus y squared. Maybe I just feel like writing them in this particular order. Minus 4y. Let's see, 25 and 4 is 29. Subtract that from both sides just for the heck of it. And maybe I'll bring everything over on the side here. Let's subtract 9 from both sides. Plus 16 equals 0. Ready? All right. Suppose you never saw that original equation, and you were presented with this equation. First off, it wouldn't even be clear what is the equation of. I mean, in a little bit you'll see maybe that's a hyperbola, maybe it's an ellipse, maybe it's a circle. But for right now, I'm just going to say I'll tell you it's a circle, and then in the next maybe 2 videos from now we'll talk about how do you even know that it is a circle. How do you even know whether it's something else? But even if it's a circle, take a look at this equation right here. You cannot tell what the center and the radius is just by looking at it. What we have to do is we have to put it back in a nice form. And the way I'm just going to go ahead and tell you how we're going to do it because it's not obvious. We need to complete the square twice with a twist. So twice, once with respect to x and once with respect to y. And let me just go ahead and show you how that plays out. First thing you want to do is group the x's and the y's. So get the x's together, get the y's together. Let's go ahead and do that. So x squared, they may be together already, but if they're not, put them together. And let's just get any plain numbers over on that side. Almost as if we're saying, let's just get them out of the way. They're distracting. Now, think about completing the square. The next thing you would do is divide both sides by the coefficient of x squared. If there had been a number here, and if this is actually a circle, if it's a circle, and there had been a number here, the same number would be there. If the coefficient of x squared and y squared are not the same, it's not a circle. So that would be one immediate tip-off that something's not a circle. But there actually is a 1 there and there's a 1 there. So both coefficients are the same. And that does, in fact, tell us that, well, it could be a hyperbola. But for right now, we haven't even talked about that. So if there had been a number here, we would divide both sides by that number. It happens to be 1, so fine, we divide both sides by 1. Now, what do you do in completing the square? You take the coefficient of x, divide it by 2, square and add it to both sides. We're going to do that. 10 divided by 2 is 5, square root 25. What but we're also going to do it with the y term. So take the coefficient of y, 4 divided by 2, square it 4, add that, and add that to both sides. But what I've really done, look, is I've added 29 to both sides. And I'm allowed to do that. That's legitimate, it's fair, it's within the rules. Right, everything's great. Let's go ahead and factor these 3. And factor those 3 just like we do in completing the square. Over here, we do all the calculations. It went up a 9. Lo and behold, that was the equation. So what you do when you have the equation of a circle, and we're going to have to do this for ellipses and hyperbolas, but when you have the equation of a circle and it's not in the nice form, you have to put it in the nice form. You put it in the nice form by completing the square twice, once with respect to x and once with respect to y. So again, this idea of completing the square, it is absolutely one of the standard tools in the toolkit of a mathematician. I mean, it's just something that you do, on a more or less regular basis. Okay, so that definitely, I think, completes 10.1. All right.